For this lesson, let's talk about diagonals and angles. My drawings are not going to be straight lines. I'm not going to try to make them straight today. So for a polygon, a diagonal is a line that crosses from one vertex to another when the vertices are not adjacent or not next to each other. So these two are opposite. So those are diagonals, but this vertex and this vertex are next to each other. So the line going across the top isn't a diagonal. But this one is. So let's do an example for a hexagon or stop sign shape. So if we're not doing the ones that are next to this, which is this one and this one, the diagonals would go from this one to this vertex to this one here. So there would be 3 diagonals, and that's from any vertex on this shape. There are 3 diagonals, and whenever you look at them, technically it cuts the shape into 4 triangles. We have 1 here, 2 here, this triangle here, and this 4th one here. And so we can say, so there are, all of these are angles of the hexagon, but they're also angles of the triangle. And so if we label this triangle A, B, C, D, E, and F, this angle here, E, in the hexagon is also the same angle for triangle DEF, right? So we know that the insides of every triangle, all of those angles added together are 180 degrees, right? So for the yellow one, this is 180. And for, let's do this first green one, that this and this part are 180. For the number 2 triangle, that angle, and this angle are 180. And let's do this last green. These angles are all 180. So 4 triangles that make up a hexagon are all of the angles for the make up these 6 angles, which, let me see if, let me pick a different color here. So angle A, angle B, angle C, angle D, E, and F, and the hexagon added all together are the same as all of these 4 triangle angles added together, which is 720 degrees. So all of the angles inside of the hexagon add up to 720 degrees. Okay. So if we divide that by 6 equal angles, right? Every single, well, here, let's do it over here. 720 divided by 6. So every angle inside of the hexagon is 120 degrees. So let's see. On this four-sided polygon, we split this in half with a diagonal. There are 2 triangles here, right? So because we know all of the angles inside of a triangle are 180 degrees, this one's the same. So 180 degrees is 360 degrees. So all of the angles inside of this polygon are going to be 360 degrees. So let's see. One thing I wanted to talk to you about too was the exterior angles. So when we're drawing the hexagon, well, let me do this. So, let me do it in a different color. Let me try to draw a circle here. And now you can put a hexagon, draw it inside of the circle. Oops, it's not perfect. So whenever you look at one of these, this is a semicircle, this is a protractor, and whenever you use this to measure angles, and if you look, one side's got a 0 for the flat part, and the other side has 180 written on it. So a semicircle goes from 0 all the way to 180 degrees, and full circles all the way around from this point to this point is 360. That's why the semicircle is 180. So if you think about drawing a hexagon, you know, we drew this first line from here to going this way, and so, but then we turned to go this way, right? Instead of going straight. But if we went straight, that would make the flat part of here, so this, all from this angle is 180 degrees, right? And so if you think about not turning, or how many turns you have for this polygon, so we turned here, so this would be 1, 2, I'm just drawing as from where we turned. So we turned 1, 2, 3, 4, 5, 6 times, 6 angles to draw this. And so going around in the circle, we're going turning in the circle 360, or we're still going in a circle. So all of these outer angles, which would be the ones outside of the circle if we had, or the ones outside of the hexagon if we hadn't turned. All of these angles are added together to get 360 degrees. And so that 360 divided by 6 is going to give us, every single one of these angles is going to be 60 degrees outside of this hexagon. So one rule for math is going to be that if all the turns are in the same direction, so we're all going around this way, then the sum of all the angles outside of any polygon are going to add to 360 degrees. So all of these 60 degrees added together 6 times will give you that 360 full circle turn. And so if you look just for the hexagon, we know that this is 60, and we know that this full angle is 180 because of the semicircle. It's, we're going halves all the way around. So this 180 degree angle, minus that 60 degree outer exterior angle on the outside is going to give us the 120 degree inside angle for the hexagon, which is what we measured earlier. So we said all of the angles inside of a hexagon are 120 degrees, right? And then it checks out that all of the outer angles inside, or all of the angles outside of the hexagon that line up and make supplementary angles, is that what it's called? Then those are 180, so we can get the exterior angles as 60. But is it? Sorry, I'm trying to see what the outside angle is called, or what those two. Yeah, so they're supplementary angles. So an interior angle, I wish it would keep that color, an interior angle of a polygon, so this, those are too close together, maybe this color, so this angle and the interior and the exterior angle are supplementary angles that make this angle 180 degrees. All right, that's all I have for this lesson. Let me know if you have any questions.